So let's check an x-axis first. Try 0.30. All right, so this top ring is out of spec. Welcome back, everybody, to another episode of Build and Drive. In this series, we're building a BMW 325i N52 B25 engine. And so far, we've taken off the head, which is under here. We found there's a cracked valve. We're going to replace that. That's been ordered. We've taken the pistons out.
Flashback.
So what I'm going to do now is I've turned the block on its side. I'm going to take off all the conrod bolts out, and we're gonna feed the pistons out through the bottom, and I'm gonna lay them out here and number them all, and then we'll take a look at the bores and measure the piston ring gap and also inspect the pistons. So let's do that right now. Got them over here. We're going to be looking at the rings, the skirts. We already did the bearings in the last video. I'll link that in the description. So now that we got this all out and apart, the piston rings look really good. They actually look like they're in good condition. Nothing's binding, nothing's stuck. Everything moves well, moves freely. The bearings, although they look like that, they're still well within specs, so I think I'm going to reuse them. So if you're interested, hit the subscribe button. We're going to be looking at all of this stuff. Okay, got all the pistons out. I already started taking apart piston number 6 just because I was curious. I took the first 2 rings off, the top compression ring and the middle compression ring. There's no problems. Everything moves freely. The grooves are nice and clean. Even the oil ring still moves freely. Normally, this oil ring will get stuck, and that's when your engine starts burning a lot of oil. I don't know if these are yet in spec, but we're going to take a look. But today we're going to be looking at the bores of the block. We're going to be measuring to see if the bores are oval and if they're conical. So for example, you know how like a plastic cup, a white plastic cup is smaller at the bottom and then it goes up, it grows bigger as it gets to the top. We want to also measure that on the block to see if the bore at the bottom is the same as the bore on the top and there's not too much of a taper. And I have the specs over there as to what's allowed. And we're also going to measure for ovalness, because as the piston is going up and down, it's also moving a bit side to side, going like this in the bore, and it wears at the sides. So we want to also test for ovalness. And what we're going to use to test that is this. Now that this is a dial bore gauge. It has a attachment on the bottom that you can set. There's various different lengths. And then here there's a little piece that will touch against the end of the bore, the walls of the bore, and then measure out how many 0.001 of a millimeter it is. So we can set this up for 88 millimeters. Sorry, the bore is 82 millimeters. We can set it up for 82 millimeters using a micrometer, and then measure the bores at 3 different parts. We're going to be measuring it at the x-axis and the y-axis. And we're going to be measuring at 3 different heights: the top, the middle, and the bottom. So here are the measurements that we're taking a look at. Bore stage 0, which is stock, is 82.007. So 7/1000ths of a millimeter, plus or minus, or plus 0.02. So I guess we're looking for, permitted out of round for each bore is 0.01. Conicity is also 0.01, and total wear tolerance between piston and cylinder 0.015. So what we're looking for is to make sure the bore is at 82.007. What I've done is I've tried my best to set up the 82 millimeters here. It's very, very close. I had to put a little washer in here to extend this a little bit because it didn't fit between the two different sizes. But then here, on my micrometer, oh, you guys may not be able to see that so well. This is a 75 to 100 millimeter micrometer. And what I'm gonna do is I'm gonna go to 80 and 0. So this number here is like 75, 76, 77, 80 millimeters. And then these are the 80 point something millimeters. 80 something point something. So yeah, 85. Okay. So every line here is actually a 0.5. So it goes 80. I'll show you. Just line it back up. See how the line here is lined up with the 0? Man, you guys can't see that, can you? Anyway, it's 80, 0.5, and then we'll do one more revolution. 81.5, back at 0, and then 82. Yeah, 82, and we're gonna look for 80.7. 82.7. Then I'm gonna tighten it down here. And then here, I'm gonna put this in the, I need 2 hands for this, but you get the idea. I'm gonna put this in the micrometer, and I'm gonna look for where the gauge ends up. I should really put this in a vise. So now that it's in the micrometer, I'm gonna turn my gauge to 0 there. Figured out a method to set the bore gauge is by putting this down on the ground. I respaced it. I put a different spacer in here, and then I set it up so that, as you can see here, even though the needle jumps around, when we go back and forth, it doesn't go below 0. So 82.007. See? It won't go below 0. So now let's take a look at this bore. I'm going to assume x-axis is left to right, y-axis is top to bottom. So let's check an x-axis first at the top. .01. Yep, 0.01. So after a fair bit of Googling and writing stuff down on paper and getting confused, I made myself this little diagram. We're going to be measuring the top and bottom of each cylinder bore. We're going to be measuring on an x-axis and a y-axis to calculate the out of round and the taper of the bore. And we're going to do that for every for every cylinder bore. The permitted bore size is 82 millimeters, which is what I've set up my micrometer to be. Yeah, we're talking very, very small values. However, that's the permitted out of round value. Now this bore gauge measures to 0.01 as well. Each revolution of this is 0.1 millimeters, so we can measure to the thousandths of the millimeter using this. So let's go ahead and measure piston number 1. So my x-axis is just going to be left to right, and my y is going to be top to bottom. I'm going to place this in about an inch down from the top of the cylinder wall, and I'm going to rock this back and forth until I find where it's zeroed out. And for this engine, it's 0.003. Try that again. Yeah, 0.003, and let's go to the bottom. At the bottom of the piston, at the bottom of the cylinder wall, you can see where the color changes from when the piston rings are landing to where they go up and down. Measure just above that, maybe a couple centimeters above that. And again, 0.03. Now let's measure the y-axis. .04 and 0.03. So now I'm just going to do the rest of them and write everything down. So again, I think we hit the jackpot with this used engine. I mean, I bought it sight unseen off eBay. The guy shipped it to me and it looked horrible. It was all burnt up. It looked like, yeah, I was gonna have to rebuild everything. And so far the numbers are looking really good. Piston 1, I mean, perfect, not out of round and not tapered. You know, it says 0.003, but maybe that's my, you know, maybe I didn't set this up right. It's well within spec. So, and we have 0.03, like piston 1 perfectly straight, nothing's out of round. This tells me this was probably rebuilt maybe 30,000, 40,000, 50,000 kilometers ago. I mean, everything's clean. I can't see the cross hatching on here though. I'm gonna take a better look. I don't see, I don't know. I have to look that up. I don't know if they, I have to think about that. I think the bores are all good. Now I'm debating, do I hone them just a little bit just to scratch up the surface to get the rings to reset? Because the rings don't really reset. Once you've taken them out, they've shifted, they moved. I think you do have to just do a quick hone bore, like using the dingleberry hone just to scratch up the surface, so when you put the rings back in, they do set. But I'm gonna Google that and make sure, or you guys tell me in the comments what you think. So now that that's done, I can put these away. I mean, with bore gauge, this was super quick. Once it got set up, I mean, it took me like an hour to set it up properly, but once I understood what I was doing, we moved at lightning speeds. So yeah, let's move on to the next step, and that's testing piston ring gap. Mainly now we want to check the piston rings on each of the cylinders. We're going to take them off and actually just measure the piston ring gap. Because I know the bores are straight, I'm just going to do check the piston ring gap with the pistons, setting the ring gap at the top because it's just easier. I don't have to flip over the block and do all that stuff and muck about. So we're going to check the top ring and the middle compression ring. I tried to print out another sheet, but pretty much piston 1, 2, 3, 4, 5, 6, top and middle ring gap. The permitted, oh no, I have to write this out. The permitted gap, I think, was 0.018 to 0.33, and the middle ring 0.3 to 0.5. So even just taking a look at these pistons, I mean, I was expecting a lot worse. So if you guys look, I'll just grab piston number 1. The rings aren't seized. They move freely. Even the oil control ring. They are not gummed up. Well, I take that back. Maybe this one is a little bit gummed up. But what I've noticed in comparing notes online is, I believe this is the updated piston design. There is a part number there, 7542057.02. The old piston ring design didn't have any oil passages here for the oil to pass through, and what would happen is it would get really badly gummed up. As you can see, there is actually quite a bit of corrosion here. Not corrosion, sorry. There's a bit of oil buildup, but you can tell that the ring passages aren't blocked, and you can tell that by shining a light in there. Do you see the hole there? Oh, nope, there it is. Do you see the hole there? Well, and that one's totally not blocked. Do you see the hole there and the hole there? So I think this is actually the new piston design. I'll have to tear apart my current E90 to see, because the oil control rings on piston 3 are pretty much stuck. They're done. So I'm going to take these piston rings off. We're going to put them in the cylinder and we're going to measure. The piston skirt looks okay. We can also measure that later using the micrometer. I think they're all good though. Everything is pointing in the direction of, we got a semi-rebuilt engine here, and it just needs a little bit of freshening up with new gaskets and such. So I think we lucked out. So this is the top ring for piston number 6, and normally you should have a marking on it that says top or anything. I don't see any markings on this. Even on the side, normally there's a little stamp, like it would have 1 square or 2 squares for middle ring or bottom ring, but you can tell which one's the top compression ring. Number 1, by just measuring it, 1.12 millimeters, just under that for the top compression ring, and the middle compression ring is 1.5, so it's a lot thicker. And the middle compression ring actually has this lip on it, and the lip should be facing down. It's a little ridge, a little step up. So if I was to draw it for you, it kind of looks like this. It kind of looks like that. There's a little ridge on there that scrapes the oil, I'm assuming, downward towards the crankcase. So make sure that when you install that little ridge is facing downward. Okay, so what we're gonna do is, I'm just going to start with piston 6 because I already had the piston rings off. I'm going to place this in here about 1 inch down, carefully. And we're going to use the top of the piston to center it. I haven't taken the oil control ring off this one, so I'm going to be careful to not push past that. You just want to center it on there. And then we're going to take our feeler gauge, which I bought. And what we're looking for on the top ring again is 0.18 to 0.33 millimeters. So I'm going to look here on the gauge, on my feeler gauge, for there's 0.1, the golden one. We're going to go to 0.18. Oh, wait a minute. Am I reading this in millimeters? Yeah. Here we go. Sorry. There's 0.18 right here. And I'm going to try and fit that in the gap. 0.20. Nope. Let's try 0.25. Try 0.30. 0.31. 0.43 on the top ring. All right, so this top ring is out of spec by 0.1 millimeter. Let's try I'm gonna clean up this middle piston ring, or let's just slap it in there. Okay. Permitted is 0.3 to 0.5. There's 0.3. Nope. 0.35, or let's just go 0.4. No. 0.35. That fits. 0.38. That fits. Okay, let's go back to 0.4. Well, that fits. 0.45. That fits. 0.5. I mean, 0.5 just fits in there. Let's try 0.53. This is confusing, guys. Nope, 0.5. .54 maybe. It's in between these two. 0.55, 0.53. Yeah, 0.53 is too small. 0.55 just fits. Let's try bigger. 0.58. No. So I'd say 0.56. All right, ladies and gentlemen. Well, piston number 6, the top ring is 0.43 and the middle ring is 0.56. And that's just out of spec by the top 0.01 and the middle by 0.06. So these rings were just worn out of spec. I'm gonna take a look at the rest now and see what's going on. So, yeah, I just finished measuring all the ring gaps for the top and the bottoms. They're all out of spec. Remember, the biggest number for the top ring is 0.33 and the biggest for the middle ring is 0.5. And as you can see, they're all above and out of spec. So they're all worn out. Piston 1 and 2, the middle rings were completely out of spec. I think maybe I was measuring a bit too easy here. As I went along, I got better so my advice for you guys is when you're doing this is to center this up, use the piston to center it in the bore evenly so it's not at an angle, and then try to fit the feeler gauge right in the middle. Just put the last bit of it on it. I was trying to like measure it like this, and that wasn't doing good because then this was shifting and moving about. But if you just use the middle part to gently fit it in between the ring gap, you don't move the ring around so much. And that was really helpful too, to measure it quicker, because when I was like trying to measure like this at an angle and it was touching, and then I'd remeasure and I'm like, oh, why isn't it working? Anyway, just make sure to use just the end to put it in between the ring gap. You'll be good to go. So the bearings are good, but the rings need to be redone. According to BMW, you can't measure the oil ring gap. So let's take one of these off and take a look at it. So the oil ring, the oil control ring, comes in 3 pieces. There's And there's one. Wow, it's very, not brittle, but it's very bendy, very weak. All right, so there's the lower one. I don't know if there's a difference between the lower and the higher. Probably not. There's the higher one. Just put left, right. Now how do you get this one off? Oh, there is. Found it. Oh, wow. This is just like nothing. It just pops right off. So I guess you can't measure the ring gap. Okay, well, I've tried to fit it in the bore. There seems to be a tiny little gap there. They seem to have, I'm assuming this is cut. Because it doesn't go on like that, it just sits like that. Okay, interesting. So this is going to be, all of this is going to have to be re-ringed. So before we move on, I just want to measure the pistons. You measure the wear on the skirts. You measure the wear from here to here. It should be, again, the size of the bore or just below the size of the bore. And BMW spec says the bore is 82 millimeters and the piston should be 81.97 to 81.99. So I'm going to go and set up my micrometer here. 80, there's 80, that's 81, that's 82. So I'm going to go to 81.97 and we're going to grab a piston. Maybe I should put this in a vise or gently put this in a vise. And we're just going to measure. Did I read this wrong? I read it wrong. One more turn. That's 81.97. Just going to tighten that down just for a second. It's actually bigger than that, which is good. Now that we're in the ballpark of what we're trying to measure here, I'm going to put this on. I'm going to loosen this up just a little bit. I'm going to find kind of center point. Then it has this little ratcheting thing that applies the exact amount of torque that's needed to turn on this. And then we can measure 82.9. The last one before 0. 82.9. So, sorry, 81.99. So this one is good. So I'm just going to go through all of these really quickly and try and measure the end there. Try and center this up. 81.97. This is a bit challenging to get the right measurement. Am I in the middle? 81.97. So I think all these pistons are good. We're gonna reuse them anyway because this is supposed to be on a budget. 82.2, so I measured that wrong. $81.97. These pistons are all still good to go. 81.97. $81.97. All right. So we just looked at all the pistons. All of them are good to go. They were all within spec. So we're gonna just put this away. So hey everybody, hope that information was useful for you. In the next video, we're going to be taking a look at boring out the block and how to do that and how to clean the surface of the block to get it ready to put back together. So if you haven't already, consider subscribing to the channel to follow along on this rebuild project, and we'll see you guys in the next video.